Hello and welcome back. In this video, we will dive into building classification model using naive Bayes algorithm. If you missed our previous video where we explored support vector machine algorithm, kindly check it out. For this tutorial, we'll be working with our iris dataset, okay? So I'll leave the link down below. You can click on it and come here and download the dataset just by clicking on this, okay? So once you download your dataset, I would like you to save it in the same working directory as your Jupyter notebook file. And once you are done with these setups, let's get started. Right, so we are going to go through 8 steps, okay? And the first one is to import the necessary libraries. So I'm just going to import them here. So we have pandas, numpy, pandas, we have joblib, we also have train test plates, and then standard scalar. We also have our Gaussian naive Bayes, okay? We have accuracy score, confusion metrics, and our classification report, okay? So I'm just going to run this. And then the next thing is to load our data set. So I'm just going to call our data and I'm going to call pd.read CSV, okay? So, and here we are to just pass in the name of our data set, okay? So which is iris dot, you have to add the extension as well, okay? Okay, so CSV, and you are going to run that. So now we can take a look at our data set, which is data frame, right? So as you can see, we have 6 columns: ID, sepal, and sepal with petal, and petal with and species. Okay. So our goal is to use these features, or our goal for the model is to be able to predict the species, okay, by providing the model with these inputs, okay. And we can also check for other information as well to know the data type. Okay. So here we have, first we have um 150 entries, okay, and these are columns. So we have 6 columns. We have their data types right here. We also have the null count. So we have 154 null counts for each of them, which means our data set is full, okay, it's clean. So we can now go ahead and then split our data. And before we go ahead looking at this data, ID won't be necessary, won't be needed. Okay, so we have to drop that, and then these four will be our features, and our species will be our label. Okay, so with that, we can now come here and then get our features. So data dot drop, and here we have to pass in the features we want, or the columns we want to drop. So we want to drop the ID and then the species. Okay, so I'll come here and then let me just copy this, and now going to paste it here, and also ID. Okay, after that, just as this one. Okay, and then for our label, for our data here, we are going to pass in our species. Okay, so our label is going to be our species column. So I'm just going to run this, and let's quickly take a look at our features. All right, so we have the sepal length, sepal with petal and petal with as our features, and we have our label, which is our columns, right? Our output. So the next thing we have to do is we have to now split our data into training and testing. Okay, so I'm just quickly going to type that. So X is called test. Okay, have Y train, and then Y test. Okay, so we are going to call our train test split function. I'm just going to copy that here. Going to paste it here. Okay, so we have to now pass in our X with our features and our label. Okay, and after that we now have to pass in our test size. Okay, we have to specify our test size, which is going to be 0.2, which is 20%. Okay, and then random states. Okay, and let's use 42. Okay. Yeah, so let's run this. Okay. So what you are trying to do here is when you take your features, our features, you are trying to split it into training and testing. Okay. And we want the test data to be 20%. Okay. And the training should be 80%. Okay. Now let's try and then take a look at our training. So 150, 80% is supposed to be 120, right? So when you come here, yeah, we have 120 rows, which means we've been able to split it successfully, right? So let's take a look at the test. So let's say info. Okay, so we have 130 entries. So we've been able to split our data successfully, right? The next thing we have to move on to is feature scaling. So we have to scale our features into a specific range, right? Which we are going to use our standard scaler. So I'll just create a variable called scaler. I'm going to call our standard scaler here. And after that, we're going to extrain and then scale. Okay, so we are going to scale our extrain. So I'm just going to call the scaler here dot fit transform. And we are supposed to pass in our extrain. So I'm going to pass extrain here. We'll do same for x test. So just going to call it scaled. Call our scaler dot fit transform. Going to pass in our x test. Okay, so we are going to scale only our features. Okay, and after that we can now run it. Now let's take a look at the scaled version. So I'm just going to create a new cell down. I'm going to copy the scaled version and paste it right here. Okay, so as you can see, our scaled version is now in array form, which the values has been scaled. Okay, now let me take a look at this one. Okay, you see now they are clearly there is difference, right? So we've been able to scale our features, and then now the next thing is to initialize our model and train it. Okay, so we are going to use our Gaussian naive base here to do that. So here I'm just going to call naive base, which is a model, a variable. So naive base model. I'm just going to call this here. Now you have to train the model. So naive base model, model dot fit. Okay. So you have to train it with our scaled version of our features. So I'm just going to pass that one here. I'm also going to pass the Y train. So Y train. Okay. Now we are going to run it. So we've been able to train our model. Okay. Now we can make predictions. Okay. So I'm just going to call the model dot predict. So we call the model and we are going to say dot predict, and we are going to pass in the scaled version of the test. Okay, so for testing, so why is it gone? Yeah, so I'm just going to pass in that one here, and now when you run it, it's giving out some output here, right? Which are the species. So let me try and then save this in a variable. So I'm just going to say y grade underscore, let's say naive base. Okay, and let me run it. So we've stored the output here. So we are going to use that to evaluate our model. All right. So I'm quickly going to write that code and I'll take you through. All right. So what I have here is, remember we imported accuracy score, we imported confusion matrix and report, right? So we use those functions here. And what I basically did here was we pass in the test, okay, our Y test, and then we pass in the predicted, okay. And with the confusion, we also pass in the Y test and the predicted, same as the report, okay. So this one, it will take the y test and then compare it with the predicted value. Okay. So the output of the actual data and then the predicted values. And then it will compare it and give us the accuracy. To do same for confusion matrix and also our report. And after that, we want to, or we print out the accuracy, the confusion matrix, and then the report, right? So let me run that here. Okay, so our model had an accuracy of 0.96667, right? And we have our confusion matrix here. Okay, we also have our precision recall and F score right here, which are part of our classification report. Okay, I think I have some algorithm here I would like to show you. All right, so this is the algorithm, and what it basically does is for every input. Okay, so the training test, the data we use to test our model, for every input, it predicts the values for the input and then the predicted outputs against the actual one. Okay, so when you let me take you through. So here we are trying to extract the input features here. Okay, here we extract the actual outputs, and here we will pass in the input features. So first you have to scale it. Okay, and when you pass the input features, we get the predicted output. Okay, so that we can print the input values, the predicted outputs, and the actual outputs. So let me run that. Yeah. So as you can see here, these are input features. Our predicted output was this, and our actual output was that. So you can just even go to your data set. So data set, and at 75, I always do this. So 75 here, this is the first input, right? And it's iris dorsal, iris vesicular, right? Which means our model did well and our algorithm is also working. So this is the for every input, right? So this thing 30, 30, right? Yeah. So this is the algorithm I wanted to show you. The next thing is to save the model, right? Now we've been able to train the model, make predictions, and now we can save it and also in future use it in our projects. So I'm quickly going to give the model file name. So let me say file name, and I'm going to say NB model. Okay, so NB model, and I'm going to use the dump, call the model here. So the model we saved was naive base model. So I'm just going to copy that, paste it here, and then the file name. Okay, just write some print statement down here. So let's say model have been saved successfully. Okay, now let's run it. Okay, our model has been saved successfully. So now let's go back to our directory. So as you can see here, we've been able to save the model as well. Okay, so that is it for this video. I hope you really enjoyed this video. If you did, kindly click on the subscribe button. If you haven't, like this video, share with friends. Let me know your comments in the comment section, and see you another time.